Does a variable speed pool pump save you money? The thing about a variable speed pool pump that a lot of consumers don't understand is that there's a scientific principle behind why and how it saves you money. Specifically, that principle is that when you turn down the RPM of an electric motor, like in a pool pump, by half, the amount of electricity that the pump is using is reduced by 8 times. So that non-linear drop in power consumption is the reason why a variable speed pump can and will save you a lot of money. And when you see if you go into a pool store, you'll see a sign that says save 80% or save 90% on your electricity with this variable speed pool pump. And then you're thinking to yourself, that sounds great, but it also kind of sounds too good to be true. It's not really, and perhaps not every single pool will be able to save 80 or 90%. However, you will be able to save a lot of money by using a variable speed pool pump, and I'm going to show you how that works specifically. As I mentioned before, there's a non-linear drop in the amount of power that a pump consumes. So just to let you know, this is a Superflow variable speed pump by Pentair. It's currently set up to run on 2-inch plumbing. The 2-inch line is open. The 1.5-inch line is isolated and closed. And on the pressure side, same thing. 1.5 inch is actually closed. 2-inch line is open. And what I'm going to show you here via this wattage meter that I've got up here, I'm going to show you specifically. So first, let's just run this pump at full speed, which is 3,450 RPM, and we'll take a look at the current draw that the pump does. Now, this is going to be loud when the pump spools up to its maximum RPM. If you're using headphones, you might want to turn down the volume just about now. Let's bring her up to full speed. So as you were able to see on the display there, when the pump is at full RPM, 3,450, it draws just about 10 amps even, perhaps 10.1, 10.2 amps, but it was fluctuating back and forth. Let's call it, just for argument's sake, let's call that 10 amps. So now what I want to do is I'm going to turn down the RPM of this pump by half. And so that's about 17. Let's see here, we're at 14 now, start dialing it up. So it goes in increments of 10, so we'll get it as close as that as we can get it. $17.25 would be half, but let's go ahead and call it $17.30, so we're being conservative by saying it's half. So the motor now has been reduced by half of the RPM. It was at 10 amps before. If there was a linear drop in the amount of power that the pump consumed, then it would be at 5 amps because that would be half. So let's take a look and see what we're consuming right now. 1.86. So 1.25 amps would be what we would expect to see for an 8 times drop in power consumption. And I do suppose that there's a little bit of power that's consumed not just by the electric motor but by the digital control and also by the meter itself here. So the numbers that we see there actually do jive. At 1.85, that is approximately an 8 times reduction in the amount of power the pump is consuming versus when it's at twice the speed, 3,450 RPM. And that continues as you dial down the RPM of the pump further. So that, in short, is the reason why variable speed pumps save you so much money. And a single speed pump can and never will be comparable to the amount of savings that you can experience by having a variable speed pump where you have the ability to turn down the RPMs and experience an exponential reduction in the electrical usage that the pump is using. If you found this information helpful, please be sure to like this video and subscribe to my YouTube channel. And you can check out my website, swimmingpoolsteve.com.